Hello everyone and welcome to our today's TRUMPF webinar on the topic laser programming and how you get from the geometry to your C program faster than ever before. My name is Vitali Pautz and today you will learn how the new Boost nesting module not only enables you to maintain a complete overview of all your outstanding orders, but also results in a better utilization of material. Furthermore, we will focus on cutting solutions for single parts, job-related nesting, and intuitive adaptation of laser processing. Before we start, just a quick reminder how TruTops Boost is structured. Basically, it's the sum of the Boost technology and the new operating philosophy. So the Boost technology contains all the automatisms and the Boost button, which start that automatic calculation. And the new operating philosophy contains the division of TruTops Boost into two levels. So the first one is called Home Zone. It's basically our control level where we manage our orders and start the calculations by pressing the Boost button. And the second level is the Tech Zone, our interactive level, where we modify the automatically generated solutions or where we create our 3D or 2D designs. So let's get started and switch over to TruTops Boost. So first of all, we import all the parts. There's a preview of GEOS and SCDocs on the right side. So we select them all and import them. In case if you have an ERP system or PPS system, it's possible to import to configure the job order interface and use an XML file. And within the XML file, you can define the customer, your drawing number, then material information, then quantity of the parts, and so on. So all the information will be imported just by configuring that XML file, and everything will be within the home zone, ready for the nesting. We have used right now the manual import, but of course there's a possibility if you migrate from TruTops legacy system that you even import or migrate your TMTs, so your nested sheets with technology. We will ignore the warning. So the warning exists in case if there's already an existing part with the same name, but even for you, in order to check whether it's really the same part, we show the area, we show this dimensions and so on, some more information. We'll see it later on. So I don't ignore it, I leave it in order to check it later. So right now let's set a finish date. Let's set a quantity value of 10, assign a customer information, and assign also the material and thickness, so there's no unfolding tool is for unfolding, and there's no bending program. We boost all the imported files. And you see how fast it goes. If there would be any open contours or gaps or anything else, we would get, with the help of the status concept, a warning, like in that case, but here's exactly what I meant before. In the system, there's already the same name, a part with the same name, and here you get the size of the file, dimension, surface, raw material, and so on, and you can basically use the existing file or ignore warning and use the new imported one. So I think it's the same part, and we'll use the existing one, and you see that it gets replaced, and of course I don't need a bending program, and we are also good to go, and the part is completed for nesting. Again, here let's ignore the warning. Now I've got probably a duplicate. I use here the existing one, and we'll see. Everything is finished by now. As we see, there are no calculations anymore. So let's select everything what we have imported and create nesting. So when we click on create nesting, you see that the category is changed. So there's an order list. We can still set other quantities or finish date or customer. We can set other quantities and unlock basically the min and max values, but I won't change it. So I'll just select my machine. I can still change my LTT and set a certain LTT as a favorite. And here, for example, there's only a small raw sheet. So I open up a new tab. I go to my material database, select my stainless steel. So that was 1 mm, and just create a new format, save it back, close it, and now I'm able to select it within the raw sheet selection and can now boost my nesting. So right now in the background, of course, the sheet is being taken. Nesting mode is optimal sheet format. So the technology is applied for all the orders within the order list, and we even generate, of course, the NC. And basically for the nesting, you can preset a certain nesting profile. So considering the part distance, the sheet margin, and the nesting algorithms themselves. So we have even developed a new nesting algorithm called Premium, and it works for single parts and multi parts as well. And of course, material savings is money saving, and it's really a good improvement. So let's check. You see on the right side a preview of the nested sheets. You see scrap, you see the processing time, and even some warnings. So, for example, if there are some collisions between processings, you'll get a warning. There are no roundings. There are some processings disabled, and the equidistant calculation has got errors for certain sheets, and we'll just open it up and see where the warnings are and how we can solve them. So that's a new user interface of Texon Cut. We have unified basically the nesting module and the technology module, and it's a really good way to work directly in one window, application window, without changing the applications, and it's much easier now to do the optimization. And basically you have your part scroll here on the top, and there's no function navigator but a ribbon, and you'll find all the functions you need within the ribbon. So let's see if we open up a sheet. You see basically the part, you see the processing, the positioning lines, so within the part and between parts, and let's see the collisions. We see already in that part that there are collisions Of course, if the two um, laser cuts interfere or don't have enough space, there will be a collision, and the slit won't be as thin as we have drawn it. So how do we solve it? It's very easy. How do we solve it? We have to open up that part within the design window. So we just scroll down within our order list, we see that order, and we open that part. So that's our new 3D design level. We need to replace those slits by a certain attribute, and there's a tab called 2D technology, and we replace slitting contours. So we just click on one of the contour, and the attribute is changed. All right, so we close the parts, save our changes. So what we do next is we just close the program and go back to our nest, delete the existing one, and just reboost it again. We haven't invested any time on optimizing the program, so it's easier just to replace it. You either can reboost your nesting, or even a smarter solution would be to re-nest that order, because we have made some adaptations, and I'll show you in a minute how it exactly works. So as you can see, there are much less warnings, and there are still a few disabled processing that exist, and that's exactly the same part. So what you do is, let's say I increase the quantity of a certain part, let's say 50, there's underproduction. Of course, I open up the sheet program within the text zone cut, and what I do next is I just go to start and re-nesting on selected sheets. So I can basically select any sheet and right now TruTops Boost tries to find enough space for those parts, but most probably it will be on the last sheet because there is plenty of space, but we'll see the result. Now, as we can see, the parts were nested. There's no underproduction, so that was that part, 50 of 50, and there was enough space found within the existing sheets, so without using the last one, and that's a good thing. In the following example, I would like to show you some special features, for example, for marking any geometry that you want to insert on your part, and basically how we treat certain forms and what to do with sinkholes, such as that hole. So it would be probably quite tedious if there would be 100 sinkholes to fill and to repair each. And you don't have to do that because Boost recognizes it and basically exports each time, if you unfold the part, the smallest radius. I would show it in a minute. Then with the cup, if you, for example, want to mark that edge with the laser, in order to know the position of the cup after punch processing, for example, after laser processing, so in order to insert that feature, there are several cutting preparation tools. And for example, we just have to select, activate the mark feature and click on any geometry of your part. So it could be any line, any kind of geometry element you create, a curve, an ellipse, anything. So you just click on mark and you see there's a processing type edge and it will be marked. So the property of that geometry, technologically speaking, will be marking. All right, that special feature of exporting 2D geometries, which I have mentioned before, is right here. So if you flat out, you see within the structure tree, the 2D export is inserted. And basically we see within the 2D export what is being marked and what's not being marked. And so the lines are just deactivated, the layout lines. Otherwise, you can basically that 2D export will be the base for your laser program. So you can still adjust, for example, that bend relief. And what you have to be careful about, of course, it will be lasered, and but the 3D model won't be updated. So if you want to create a special laser cutting program without modifying your 3D model, it's possible. But you have basically to be careful that it won't rebuild your 3D model, but vice versa. You can adjust your 2D export without editing your 3D model. That's the big advantage. In case you want to add some text, it's very easy. You go to detail, you insert a note. So that would be, let's say, the engraving. What you do again is you select the text, right click on your note, and you can convert it to an engraving just by right clicking it, and you see that it's converted to a lightweight note. So you see the property of the engraving is basically within the sheet metal part structure, and it will be engraved when we produce it on the laser. So we save it back and look for other examples. In the next example, I'd like to show you how to create cutting programs so that you are able to optimize your parts. Let's say you want to insert some micro joints, or you want to be the approach position on a certain position. It's very easy. So you go to your single part, you create a new cutting program. You can give it a name, for example, for a special feature. Then you select your machine, you select your angular position. So one application case would be the consideration of the rolling direction, so that the part should be only laid in 0 and 180 degrees. And what you do, you just open it within the text zone cut, and you process the part according to your specifications. So first of all, you select your laser technology table. You can disable the warnings, pierce line standard, and you click on OK. What you see is basically the single part modification window. What you can do is to create your processing. If you want to change, for example, the approach, let's say we want to center it. So we just modify our part. And we want the upper approach to be up there. And we'd like to optimize So what we can do, of course, you can simulate. Stop it, we save it back. So of course we don't create the in-C program. What you see within the home zone, there's our notification or note. You see that it was changed manually, and that's our favorite cutting program. So you could create several cutting programs, and of course for different machines, for the punching machine and another processing, and for example for the night shift, you would create parts with micro joints, and exactly that cutting program which you specify within the nesting will be taken. And that's a very good, it's a big advantage of you to keep track of your production. But let's go back to our nesting, which we have created before, and modify some features. So I'd like to show you special features such as modification of very easy modification of your nesting. So just delete that. I grab the part which I have up there, and just to show you some manual modification features. So you can either, for example, change the angle position, and so we have created the processing, and as you can see, if you, for example, modify the position and the distance between the parts, the technology is of course kept, and so after we have changed the distance, it's also very easy to insert sheet cuts, for example, in a grid style, and if you want, for example, to create parts 500 by 500 millimeters, we just specify where to start in X and Y, and you see a preview, and after that the sheet cuts are inserted. Of course, we can specify whether it's done at the end or at the beginning, or in a sequence, basically. Alright, what we do next is we just try out a few functions such as flyline, and there's a nice part for that. You see it here. What I do is I just delete the technology and reinsert it again and show you how to program it. So I activate the function flyline, and there are several options whether we want to program circles or oblong holes or other features. What you see, you just modify your, so those would be rectangles. You just select them, click on your check mark, and then they are then being programmed. So that's how easy flyline programming is. For example, if you want to cut scrap, it's also very easy. You go over to your cut scrap automatically feature and just specify the hole which you want to cut. If you want to modify the distance between the cuts, it's within the settings. So there's a grid, 12 millimeters would be here, the distance, and again I'm specifying my function which I want to use, and what you see is basically all the scrap will be cut. Of course it takes more time, but in case you want to analyze all your tilting parts or tilting contours, that would be one possible solution, how to prevent collisions, for example, with tilting parts. But of course, you could insert a microjoint, or there's another option even called Smart Collision Prevention for laser, which you could check up on TrumpTube, or you just can get some information on the website. We can, of course, even cut up that sheet, and as you can see, there were also 500 by 500 cuts inserted. Sheet cuts. So again, 500 by 500. So as you can see, it's very easy to modify anything. For example, if I right-click on that approach line, it's very easy to invert the processing or to delete the processing or to get information in order to see whether it's being cut with big contour or small contour. So within laser, the aim was to make it more user-friendly and basically so that you can work more intuitively and in a better workflow. So I go back to my plane view and generate the C program for all the sheets again. Alright, we close that nesting, save the changes. And in the last step, we would release the program into the machine folder. So we've seen in that webinar how easy it is to program in a very fast way, how easy it is to create special cutting programs and to use them within the nesting, and how user-friendly it is to insert marks, engravings within the 3D model, and even to modify the 2D export within the 3D model and still modify it. So thank you for watching. If you have any questions, don't hesitate to write to us. And for the next webinar, it's a small preview. I would like to introduce punch programming and why it is easier than ever before. And if you have any ideas, also write to us and we'll be glad to take it into consideration in our webinar program. Thank you very much and have a good day. Bye-bye.